March 27, 1945. Paderborn, Western Germany. 14:37 hours. The deep rumble of a Maybach HL-230 engine echoed through the ruins of what had been a prosperous industrial town before American artillery had reduced it to broken concrete and twisted steel. Technical Sergeant Robert Morrison stood 50 meters from the massive Panzerkampfwagen 6 Tiger II, the King Tiger, as its transmission ground with a metallic shriek that spoke of impending mechanical failure rather than the mechanical invincibility that German propaganda had promised. The smell of overheated gearbox oil mixed with the acrid stench of burning buildings, creating an olfactory portrait of a weapon system that represented the zenith of German armored engineering and simultaneously exemplified the fatal disconnect between theoretical excellence and practical sustainability. The sound that dominated Morrison's attention was not the powerful engine note, which remained impressive despite the mechanical distress, but rather the irregular clattering from the final drive assembly, a rhythm that any experienced tank mechanic recognized as the acoustic signature of imminent catastrophic failure in a transmission system that had been designed with inadequate safety margins and manufactured with materials that substituted hope for proper metallurgical specifications. Morrison's maintenance crew had been tasked with evaluating captured German armor for the U.S. Army's Ordnance Department, documenting technical characteristics and assessing combat effectiveness of vehicles that Allied intelligence needed to understand if similar designs appeared in future conflicts. The King Tiger that idled before him, captured intact 2 days earlier when its crew abandoned it after the transmission locked during a retreat through Paderborn's outskirts, represented the most formidable tank the Wehrmacht had fielded, mounting an 80mm KWK-43 L-71 gun, capable of penetrating any Allied tank at ranges exceeding 2 kilometers, protected by frontal armor up to 185 millimeters thick that could defeat every Allied anti-tank weapon except at point-blank range, and carrying the psychological weight of German technical superiority that had characterized armored warfare since the Blitzkrieg campaigns of 1940. Yet this particular King Tiger, serial number 280314, had traveled approximately 120 kilometers from its delivery point before mechanical failures had rendered it a static pillbox, then abandoned scrap, and finally an American intelligence asset that would reveal more about German military-industrial collapse than about German engineering excellence. The engine sound, that deep, throaty rumble of the 12-cylinder Maybach running at idle, had become for Morrison a symbol of the contradiction that characterized late-war German armor. The King Tiger's power plant was a masterpiece of engineering that produced 700 horsepower through precision-machined components, represented thousands of man-hours of specialized labor, and required materials and manufacturing capabilities that Germany's war economy could barely sustain. Yet the same economic pressures that made each King Tiger a triumph of industrial persistence also ensured that critical components were manufactured with substitute materials, that quality control was sacrificed to meet production quotas, and that the mechanical complexity required to achieve the tank's theoretical capabilities exceeded Germany's ability to maintain that complexity under field conditions. The sound of the Maybach engine was magnificent, powerful, smooth, the acoustic expression of high-performance engineering, but it was also the sound of unsustainability, of a military technology that required resources and industrial infrastructure that Germany no longer possessed, of a weapon system that was simultaneously the most capable tank in the world, and a strategic liability whose maintenance demands exceeded its tactical contributions. This moment, an American maintenance sergeant listening to a captured King Tiger's engine deteriorate in real time, exemplified the terminal phase of German armored warfare and the broader collapse of the German military-industrial system that had launched the war with such confidence in technological superiority. The King Tiger represented the culmination of German tank design philosophy, incorporating every lesson learned from Eastern and Western Front combat, mounting the most powerful tank gun deployed by any nation during World War II, and protected by armor that made it effectively immune to frontal engagement by conventional Allied tanks. Yet it also represented the dead end of a development path that prioritized individual vehicle capability over operational sustainability, that demanded manufacturing precision and material quality that Germany's collapsing economy could not reliably provide, and that required logistical support and mechanical maintenance at levels that German field forces could not sustain, while conducting fighting retreats across multiple fronts. To understand why the King Tiger's engine became both its greatest strength and ultimately a symbol of German strategic failure, one must first comprehend the evolution of German armor doctrine and the industrial context in which late-war German tanks were developed and fielded. German armored forces had entered World War II with tactical and operational doctrines that emphasized combined arms coordination, battlefield initiative, and the use of armor as breakthrough forces that would exploit gaps in enemy lines rather than engaging in direct tank versus tank combat. Early German tanks, the Panzer III and Panzer IV, reflected this doctrine, mounting guns adequate for defeating contemporary Allied armor while emphasizing reliability and ease of maintenance that allowed sustained operations deep in enemy territory. The Eastern Front's reality challenged these assumptions fundamentally. Soviet T-34 and KV-1 tanks encountered in 1941 demonstrated that German tank guns were inadequate against well-armored opponents, that German armor protection was insufficient against Soviet 76. 2mm guns, and that the quantitative advantages Soviet production could achieve required German tanks to possess qualitative superiority sufficient to defeat multiple Soviet tanks in succession. German response was to escalate, to design heavier tanks with more powerful guns and thicker armor, accepting the increased mechanical complexity and reduced mobility that this escalation required. The Tiger Y, introduced in 1942, represented the first step in this escalation, mounting an 88mm gun and protected by armor that made it effectively immune to most Allied anti-tank weapons. The Panther, introduced in 1943, attempted to combine heavy armament and armor with the mobility and reliability that German armored doctrine had originally emphasized. The King Tiger, designated Panzerkampfwagen 6X Auswinter B and introduced in 1944, represented the culmination of this escalatory path. It mounted a longer, more powerful 88mm gun than the Tiger I, was protected by significantly thicker armor optimized against the latest Soviet anti-tank weapons, and incorporated design improvements based on combat experience. But the King Tiger also weighed approximately 70 tons in combat configuration, more than double the weight of the Panzer IV that had been Germany's standard medium tank at the war's beginning, and this weight imposed mechanical demands that pushed German engineering and manufacturing capabilities beyond their sustainable limits. The Maybach HL-230 engine that powered the King Tiger was theoretically adequate for the tank's weight, producing 700 horsepower and providing a power-to-weight ratio comparable to earlier German tanks. But the transmission and final drive assemblies that transferred that power to the tracks were fundamentally inadequate for the stresses that a 70-ton vehicle imposed. The transmission, adapted from designs developed for lighter tanks, experienced catastrophic failure rates that made mechanical breakdowns more common than combat losses in many King Tiger units. The final drives, which bore the mechanical stresses of accelerating and maneuvering the massive vehicle, fractured with alarming frequency, often after fewer than 500 kilometers of operation. The track assemblies, which had to support unprecedented weight while maintaining grip on varied terrain, wore rapidly and required constant maintenance that German logistics could barely provide. The sound of the captured King Tiger's engine, powerful and impressive despite the transmission damage, became for Morrison a symbol of German military culture's fundamental miscalculation about the relationship between technical excellence and strategic effectiveness. German engineering had produced a tank that was technically superior to every Allied equivalent, that could destroy Allied tanks at ranges where Allied weapons could not effectively respond, and that represented the theoretical pinnacle of armored warfare as German doctrine had evolved. But German engineering had produced this technical marvel within an economic and industrial context that could not sustain it operationally, that could not provide the spare parts and maintenance support that the tank's mechanical complexity demanded, and that could not reconcile the resource investment required to produce and sustain King Tigers with the strategic necessity of producing simpler, more reliable weapons in quantities sufficient to contest Allied material superiority. The evaluation that Morrison's team conducted over the following days documented this contradiction in meticulous technical detail. The King Tiger's main armament was exceptional. The 80mm KWK-43L71 gun could penetrate 200 millimeters of armor at 1 kilometer, far exceeding the penetration capabilities of American 75mm and 76mm tank guns. The tank's frontal armor, sloped at optimal angles and up to 185 millimeters thick, was effectively immune to most Allied anti-tank weapons except at very close range or through flank attacks. The tank's fire control system, incorporating advanced optics and mechanical computing devices for range estimation, enabled first-round hit probabilities that exceeded Allied capabilities. In every measurable technical parameter, firepower, protection, fire control, the King Tiger was superior to the M4 Sherman tanks that constituted the bulk of American armored forces and comparable to or better than the Soviet IS-2 heavy tanks that were the King Tiger's intended opponents. Yet the maintenance inspection revealed mechanical fragility that made the technical superiority operationally irrelevant. The transmission showed wear patterns indicating that it had been operating beyond its design tolerances, with gear teeth exhibiting stress fractures and bearing surfaces showing inadequate lubrication. The final drive showed evidence of multiple repairs, with welded patches indicating that field maintenance crews had attempted to extend operational life beyond what the original design could provide. The engine, while mechanically sound, showed evidence of operating on low-quality fuel that had left carbon deposits throughout the combustion chambers and fuel system. The electrical system used insulation materials that were degrading prematurely, suggesting that substitute materials had replaced the proper specifications. The track links showed wear patterns indicating they had been manufactured from steel with inadequate hardness, probably due to alloying element shortages that forced German industry to produce tracks that met dimensional specifications but not metallurgical requirements. The sound of the Maybach engine, running during these inspections, was both impressive and profoundly sad. Impressive because it demonstrated that German engineering could still produce mechanically sophisticated systems despite the industrial collapse surrounding their production. Sad because it represented wasted potential and misdirected priorities. Each King Tiger required approximately 300,000 man-hours to produce, consumed materials and manufacturing capacity sufficient to produce several simpler tanks, and diverted resources from other military production that might have provided greater strategic benefit. The 489 King Tigers produced during the war represented an enormous industrial investment that yielded negligible strategic return. The tank's combat effectiveness was frequently negated by mechanical unreliability. Their tactical superiority was offset by their scarcity, and their psychological impact on Allied forces was countered by the recognition that King Tigers could often be bypassed and left stranded when their mechanical failures inevitably occurred. Morrison's report to the Ordnance Department documented technical specifications with professional precision, but his personal observations captured the emotional and strategic dimensions of what the King Tiger represented. He wrote in a letter home that the captured tank was the most impressive piece of military equipment I've ever examined, and also the most pointless. It's like they built a race car when they needed a truck. Put all their best engineering into making something spectacular instead of something that would actually help them win. This assessment, rendered by a technical sergeant whose expertise was mechanical rather than strategic, captured the fundamental criticism that post-war analysis would level at German late-war armor development, that it prioritized individual vehicle capability over operational sustainability, that it reflected institutional and ideological commitments to technical excellence, that ignored strategic realities, and that it exemplified the broader pattern of German military-industrial policy that emphasized wonder, weapons over practical effectiveness. The King Tiger's mechanical vulnerabilities were not secrets to German tank crews who operated them. Unit records and personal accounts document the frustration that crews experienced with vehicles that were theoretically invincible but practically unreliable. Crews learned that the King Tiger could destroy any opponent, but might not reach the battlefield due to transmission failure. They developed tactics that minimized maneuvering to preserve the fragile final drives. They became expert at field repairs, cannibalizing disabled vehicles for parts to keep others operational, improvising solutions to mechanical problems because proper spare parts were unavailable. The experience of King Tiger crews was characterized less by the invincibility that the tank's capabilities promised and more by the vulnerability that mechanical unreliability imposed, being stranded behind enemy lines due to breakdown, being forced to demolish their own vehicles when repairs were impossible, watching Allied tanks bypass their immobilized positions because the King Tigers had become static pillboxes rather than mobile combat vehicles. The sound of Allied artillery and aircraft omnipresent by 1945 provided acoustic context for the King Tiger's mechanical failing. Morrison heard American artillery firing in the distance as he evaluated the captured tank, heard American aircraft overhead, and recognized that even the most capable German armor was operating in an environment where Allied firepower superiority was so overwhelming that technical advantages in tank design mattered less than they would have in the war's earlier years. The King Tiger could destroy any Allied tank in single combat, but Allied doctrine had evolved to avoid giving German heavy tanks the ideal engagement conditions that their technical superiority required. Allied forces used artillery and air power to suppress German armor, used numerical superiority to attack from multiple directions simultaneously, and developed tactics that exploited German heavy tanks' mechanical vulnerabilities and limited numbers. The evaluation of the captured King Tiger revealed details about German manufacturing that were as significant as the technical specifications themselves. The tank's construction showed evidence of cost-cutting and material substitution that reflected Germany's industrial desperation by 1945. Welds showed inconsistent quality, suggesting inexperienced welders or inadequate supervision. Some components showed machining marks indicating they had been produced on worn tooling or by operators without proper training. Materials analysis would later reveal that substitute alloys had been used throughout the vehicle, compromising strength and durability in ways that were not immediately visible, but that contributed to the mechanical unreliability that characterized German late-war armor. The King Tiger that Morrison evaluated was not a representative example of German engineering excellence, but rather a representative example of what German industry could produce under conditions of strategic bombing, raw material shortages, and labor force degradation that made consistent quality control impossible regardless of nominal design specifications. The Maybach engine's sound, that deep, powerful rumble, remained impressive throughout the evaluation period, but it could not disguise the reality that the tank as a complete system was a failure of strategic procurement and operational deployment. The engine represented German engineering at its finest, produced by a company that had decades of experience in high-performance automotive engines, built with precision that reflected German manufacturing traditions. But the excellence of the engine made the inadequacy of other components more glaring. It was as if German industry had poured its remaining expertise into one subsystem while allowing others to deteriorate, to the point of failure, creating a weapon that was unbalanced and ultimately ineffective, regardless of the excellence of its best components. The transformation in American understanding of German armor that the King Tiger evaluation facilitated was significant. Early war assessments had sometimes overestimated German technical capabilities, treating German armor as uniformly excellent and German engineering as superior to American equivalents. By 1945, with access to captured vehicles and comprehensive intelligence about German production processes, American evaluators recognized that German armor development had followed a path that emphasized quality over quantity in ways that were strategically counterproductive. The King Tiger exemplified this pattern. It was the best tank of the war by many technical measures, but it was also an example of how focusing on individual vehicle capability could produce weapons that consumed disproportionate resources while providing insufficient strategic benefit. Sound of the captured King Tiger's engine running for the last time before American crews shut it down for transport to the United States, where it would be displayed as a war trophy and studied by American tank designers, was the sound of a weapon system that had never been used as its designers intended. The tank had been designed to dominate the battlefield, to destroy Soviet armor in the defensive campaigns that Germany was fighting by 1944, to provide qualitative superiority that would offset Soviet quantitative advantages. Instead, it had broken down during a retreat, had been abandoned by its crew when repairs proved impossible, and had been captured intact by an enemy that would study it not to learn how to replicate German engineering, but rather to learn how not to develop armor, how not to let technical excellence override operational practicality, how not to invest resources in wonder weapons when simpler designs would serve strategic objectives more effectively, how not to pursue capability escalation beyond the point where manufacturing and logistics could sustain it. The symbolic significance of the King Tiger's engine sound extended beyond its immediate military technical context. The Maybach HL-230 represented the culmination of German automotive engineering traditions, the application of expertise developed in luxury automobile production to military applications, the assumption that precision and performance would translate into battlefield effectiveness. This assumption was not entirely wrong. The King Tiger was undeniably effective when it worked, but it was incomplete because it failed to account for the industrial and logistical context in which late-war German forces operated. The sound of that powerful engine was also the sound of German strategic culture's fundamental misunderstanding about modern industrial warfare, that wars were won through technical excellence and tactical proficiency rather than through industrial capacity and logistical sustainability. That quality could substitute for quantity. That individual brilliance could overcome systematic advantages. Morrison's evaluation team documented this misunderstanding in technical language that focused on mechanical specifications and operational reliability metrics, but the implications extended into strategic and ideological dimensions. The King Tiger represented German military culture's aesthetic preferences and value systems, a preference for complex solutions over simple ones, an emphasis on individual heroism over systematic competence, a faith in technical superiority as a decisive advantage regardless of quantitative disadvantages. These preferences had served Germany well in the war's early years, when German forces faced opponents whose industrial capacity was not yet mobilized, whose tactical doctrines were not yet adapted to mechanized warfare, and whose organizational effectiveness was not yet optimized for modern combat. But by 1945, these same preferences had become liabilities that produced weapons like the King Tiger, technically impressive but strategically irrelevant, consuming resources without providing proportional benefit, exemplifying an approach to warfare that industrial opponents like the United States and Soviet Union could defeat through systematic application of material advantages. The final sound that Morrison heard from the captured King Tiger was not the engine running but rather the metallic clunk as the transmission finally locked completely, the final drive assembly having fractured internally in a way that made the vehicle immobile even with engine power available. This sound, sudden, final, unmistakable, was the acoustic signature of mechanical death, the moment when a weapon system transitioned from damaged but repairable to irretrievably broken. It was also the sound of German armor development's ultimate failure, the moment when the gap between theoretical capability and practical sustainability became absolute, when the King Tiger became not a tank, but rather a monument to engineering ambition that exceeded strategic wisdom. The captured King Tiger was eventually transported to the Aberdeen Proving Ground in Maryland, where it joined a collection of Axis vehicles that American engineers studied to inform post-war armor development. The lessons learned from the King Tiger were predominantly negative, cautionary examples of design paths to avoid, demonstrations of how not to balance competing requirements, evidence of what happened when theoretical excellence was pursued without adequate attention to manufacturing, feasibility and operational sustainability. American tank design in the post-war period would emphasize reliability and ease of maintenance as primary requirements, would insist on spare parts availability and logistics support as design constraints, and would reject capability escalation beyond the point where industrial production and field maintenance could sustain it. These principles reflected lessons learned partly from American operational experience, but also from studying German tanks like the King Tiger that demonstrated the strategic futility of pursuing technical excellence without ensuring operational sustainability. The sound of the Maybach engine in that captured King Tiger, powerful, impressive, ultimately futile, echoes through military historical memory as a symbol of technological hubris and strategic miscalculation. It was the sound of German engineering, at its finest, applied to a weapon system whose deployment context ensured that its excellence would not and could not translate into strategic effectiveness. It was the sound of resources misdirected and priorities distorted by institutional cultures that valued technical sophistication over practical effectiveness. It was the sound of a military-industrial system that had lost the ability to distinguish between what was possible and what was strategically useful, that continued producing increasingly capable weapons even as the industrial and logistical foundations required to employ those weapons effectively collapsed around them. When Morrison shut down the captured King Tiger's engine for the final time before its transport, when that powerful Maybach fell silent and the mechanical symphony of a running tank engine ceased, the silence that followed was more than the absence of sound. It was the silence of German armor dominance ending, of the technological advantages that had characterized German armored warfare being systematically negated by Allied numerical superiority and industrial capacity, of an approach to military technology that emphasized individual vehicle excellence being defeated by an approach that emphasized systematic competence and material abundance. The King Tiger had been Germany's deadliest tank, mounting the most powerful gun and protected by the thickest armor, representing the apex of German armored engineering. But its engine had betrayed it, not through mechanical failure alone, though that was constant, but through the deeper betrayal of promising capabilities that German strategic circumstances could not sustain, of requiring resources that German industry could not provide, of demanding maintenance and logistics that German military organization could not deliver. The epilogue of the King Tiger story is that the tank represented Germany's military-industrial predicament in miniature, capable of producing technically excellent weapons, but incapable of producing them in quantities or with the reliability that strategic effectiveness required, able to win tactical engagements but unable to convert tactical success into operational advantage because the industrial and logistical foundations of sustained operations had degraded beyond repair. The sound of the Maybach engine was magnificent, but it was also ephemeral, lasting only until the next mechanical failure, which came quickly and inevitably because the industrial system that produced the tank had already failed, even if the tank's specific components had not yet broken. That sound, preserved in Morrison's memory and in the historical record that documented his evaluation, remains a testament to the gap between what technology can achieve in theory and what strategic circumstances allow in practice, between engineering excellence and operational effectiveness, between what can be built and what can be sustained. The King Tiger was Germany's deadliest tank, but its engine betrayed it by demanding an industrial and logistical infrastructure that Germany no longer possessed, by requiring resources that could have been better employed producing simpler and more reliable weapons, and by representing a development path that led to a dead end where technical sophistication became strategic liability rather than strategic advantage.